Okay, this lesson is for Unit 8, Lesson 2 with rational numbers. A rational number is any number that can be expressed as a simple fraction. So just some examples of rational numbers. You could have whole number values or integer number values because an integer can be written as a fraction over 1. So this would be a rational number. If you have terminating decimals, so for example 0.25, 0.25 can be written as a fraction, so 1/4. So yes, this one is a rational number. I forgot the fraction bar here. So if you have repeating decimals, so 0.333 repeating, I can write that as a fraction, so as 1/3. So that is also a rational number. Looking at square roots, if the square root has a perfect square, if it's a perfect square number, and you take the square root of it and you get a whole number, then it is also a rational number because I can then write that whole number as a fraction over 1. And an example that is not a rational number, if I take the square root of 2, so I take the square root of 2, I end up with a decimal that goes on and on and on. When I actually take the square root, I have 1.4142135, and these numbers keep going on. Notice that this decimal looks different. We had a terminating decimal that I could write as a fraction and a repeating decimal that I could write as a fraction. But if you end up with a number that goes on and on and on, doesn't have any repeating chunks, and it's not a terminating decimal, then that is not a rational number. This is what we call an irrational number. And the most common one is pi, the number pi, 3.14159, and so on. If you end up with a decimal that looks like that goes on and on and on forever, doesn't stop, doesn't repeat, that is not a rational number. That is an irrational number. So let's take a look at some rational numbers. I want you to take a look at this list of numbers and think about which ones you would identify as rational numbers. Going through the list, I have the square root of 36. Square root of 36 is 6. I can write that as a fraction, as 6 over 1, so this one is rational. Negative 8 is rational because I could write it as negative 8 over 1, so that's a rational number. Square root of 14, if I calculate that out and I get the square root of 14, I end up with a decimal that goes on and on and on forever. It doesn't repeat, it doesn't stop, so square root of 14 is not a rational number. 3/5 is already written as a fraction, so 3/5 is a rational number. 2.94 is a terminating decimal, meaning it stops. I can write that as a fraction. So 2.94 is a rational number. Pi is not rational because it's a decimal that doesn't repeat and doesn't go on, and it doesn't stop. So pi is not rational. It is an irrational number. Here we have a repeating decimal. This is a rational number because I can write this as a fraction. And 56. I could write it as a fraction over 1, so 56 is a rational number. To compare rational numbers, you can use different methods. You could convert them all to a decimal and compare to see which decimal is larger. You could find the greatest common denominator between the two fractions and rewrite the fractions. Or you could use cross products, so multiplying diagonally and comparing them that way. Either method you could use, any of those. To compare using decimals, you would want to convert each fraction to a decimal. So 8/13, if I divide that out, 8 divided by 13, I would end up with 0.615, and it does have more, but I'm going to round it, so 0.615. If I convert 11/16 to a decimal, 11 divided by 16, I end up with 0.6875. So comparing these two fractions, the 0.6875 is larger, So you'd put your 8/13 is less than 11/16. You'd put your less than symbol in, showing that 11/16 is larger. Comparing these two, I have a negative 5/6 and a negative 6/7. So 5 divided by 6 is a negative 0.83 repeating. 6 divided by 7 is a negative 0.857. Negative 0.857. Now be careful, these two are negatives. The one that is actually larger, it seems to be the opposite of what you'd think. Since they're negative, this one is closer to 0. So this one is actually the larger number. So we'd want to put our greater than symbol in there, showing that it's larger. So comparing with decimals, divide out numerator divided by denominator, and you compare the two decimal values. If you compare using the lowest common denominator, you want to look at the two fractions and figure out what the least common denominator is, and then rewrite the fractions. So I have 7/12 and 5/8. Thinking about the lowest common denominator that they would both share, thinking about multiples, so 12 times 1 is 12, 12 times 2 is 24, 8 can go into 24, so the least common denominator is 24. So you want to rewrite so that the fractions have a denominator of 24. And to know what to multiply by, 12 times 2 is how we get 24. So 7 times 2 is going to give us our new numerator. So 7 times 2 is 14. Over here, 8 times 3 is how we get to 24. So 5 times 3 is how we get to our new numerator, which is 15. And 15/24 is larger. You look at the numerators then once the denominators are the same. This next example, 4/15 and 3/13. These ones aren't going to share a common denominator until you just multiply them by each other. So 15 times 13 is 195 is our new denominator. And so we multiplied 15 by 13 to get 195. So 4 times 13 is 52. On our second fraction, 13 times 15 is how we got to 195. 3 times 15 is 45. 52 is larger than 45, so we'd put the greater than symbol in for that one. So comparing with least common denominator, you need to rewrite the two fractions and then compare the numerators for which one is larger. And the last method is to use cross products. So multiplying diagonally. So A times D, so 3 times 16, and then C times B, or 11 times 5. So multiplying 3 times 16, we end up with a negative 48. Notice this negative here. And then 5 times 11, we have a negative 55. Negative 48 is a larger number. It's closer to 0, so we would put our greater than symbol in. This other one, they're mixed numbers and an improper fraction. You first want to rewrite this to be an improper fraction. So 5 times 8 is 40. 40 plus 3. This is actually 43/8, and comparing that with 49/6. So using our cross products, 43 times 6, we end up with 258. So 43 times 6 is 258. And then 49 times 8, multiplying the other way, 392. So we would put our less than symbol in between these two. 258 is less than 392. So those are the three methods you can use for comparing rational numbers. The next part is with ordering the numbers from least to greatest. So using the different methods you've used, you can either convert them all with the same denominator or convert them to fractions and compare. So if I have, if I convert to decimals, so 7/8. 7/8 is actually 0.875. 8/10 I know is 0.8, and 11/13 is 0.846. So to put them in numerical order, the smallest one, least to greatest, the smallest one is 8/10 at 0.8. So we'd list 8/10, and then 0.875, 0.846. This one is the next smallest. So 11/13, and the last one, 7/8 is our largest number. Comparing the next one, the first one is already a decimal. 64 divided by 25 is 2.56. 27 divided by 10 is 2.7. So least to greatest. Here's our smallest decimal. This one is 2.58. This one is 2.56. So our smallest decimal, or smallest rational number, is 64/25. Next smallest, 2.58. And the largest number is the 27/10. And our last one, note these ones are negative, so watch for that when calculating those. So dividing out as a fraction, 7 divided by 13, and since it's negative, it's a negative 0.53. 3 divided by 5, we have a negative 0.6, and then 5 divided by 8, we have a negative 0.625. So the smallest number is the number that's farthest away from 0. Our smallest one, the least to greatest, our smallest is this negative 0.625. So we'd list a negative 5/8, and then our negative 0.6, so negative 3/5, and then our negative 7/13 as our largest number. And the last part of this lesson is to find a rational number between. So if you don't have to find the one exactly halfway, you can just convert the two to a decimal. So 14 divided by 31 is a negative 0.45 rounding. 17 divided by 33 is a negative 0.51 repeating. So we would just need any number that would fall between these two. And you could just list it as a negative 0.5, because on our number line, negative 0.5 would fall between those two numbers. If you need the number that is exactly halfway, then you need to rewrite the fractions with a common denominator, add them, and divide in half. So if you just need one number between any rational number, you can just convert to a decimal and list any number between. There's an infinite number between. But if you want exact ones, you need to convert these to like fractions with common denominators, and then add them together and divide in half. So to find the decimal that's exactly halfway through, you need to rewrite each fraction with a common denominator. And the common denominator is multiplying these two denominators together. So we rewrite this fraction by multiplying the numerator and the denominator by 33 to get 462 over 1023. And other fraction, we multiply top and bottom by 31 to get 572 over 1023. And then it's like finding the average of the two. So you add the two numerators together. So a negative 462 plus a negative 572. And that's how we get a negative 989 over 1023. And then to divide it in half, divide by 2 is the same as multiplying by 1/2. So multiplying by 1/2, you end up with negative 989 over 2046. And if you were to convert this to a decimal, you would end up with approximately a negative 0.48, and this decimal, notice, falls between these two decimals. This one just happens to be exactly halfway through. This one over here was just any rational number between the two. So any rational number, convert to a decimal and list one between the two. If you need one exactly halfway, rewrite to a common denominator and then divide in half.